So, welcome to part 4. I had some real trouble with the table legs in this one. So yeah, I am just going to close this down. I managed to make it work. Listen, it was so long. It was unbelievable. I'm not going to save the project. Yeah, relinquish. This is the end product. This is what we'll get to at the end, and then if you want to see how it works, go back to part 0. I'm just going to say new. So what I'm going to do is I'm going to create one project which will take in all those 3 other pieces, so the legs, the tabletop, and the supports underneath. So file, new, family, metric, generic, face-based. Right, so I need to recreate all those parameters you've seen me create previously. The reason is we need to create them in this compiled view. You could really use the previous models like the tabletop. You can import the other pieces into that one and do it all there, but I like to do it this way because this is the way, it is the most efficient way, really and truly. If something breaks, you can just fix that piece and then bring it in, and it won't create other problems. That's my reasoning. So I'm going to type RP for reference plane 1000 1 2 3 4. Type DI for dimension that equal, I missed it, I'll get it in a minute, equal that to that, that to that, equal. So I will call this one length, and I'll call this one width. M, and then come to the front, click that, hit CS for create similar, there to there, DI, height, oh sorry, call that one height. I'm going to name this one table, name the reference plane table, yeah. Now, as I said, I like to open up each individual part, so the leg, and load it in. So I will load into project, so family 7 is the project. I'm going to close that compiled table just to prevent confusion. I'm not going to place it anywhere. I'm going to now close everything down, open the support. As you can see, that's just the way we left it. Load into project, family 7. And then I'm going to open the tabletop 2. Load into project. Okay, now what I will do is I'll take all of those generic models they're in, leg, support, and tabletop. Oops, I'm going to delete that one. I want it to be on this face, so change it to consistent. Well, I'll change it to realistic. I don't like the lighting of that, but whatever. So remember, we made a reference plane up here somewhere. You can't see reference planes in 3D mode, but I'm going to edit the work plane of this one, and I'm going to change it to the name of that reference plane. It's called table. And same with these. I'll hit Control and pick them both. Edit work plane, table. As you can see, they're upside down, so I will select it and flip. Select that one and flip. Now you can see they are all at the bottom of the table where they should be. So now we'll go to plan view and we will align things. AL for align. This center point, center reference to the center of the table, and lock. That one to the center of the table and lock. Now I want the table to take the length and the width of this project, because it has its own length and width, which I can change there, over here. But when I load this into a project, I won't be able to edit it. In fact, no, I'm not going to show it to you. You can try that yourself. Imagine we'll try loading this into a project and seeing if you can edit the length and width of the table. You'll find that you can't. The only way to do that is by putting the parameter in here, which is why I created those parameters, and telling Revit that these parameters will apply to this particular family. And then you can use these parameters to apply to multiple families that you load in if you want for more advanced things. So select that, say edit type and length. The length will be the length and the width will be the width that we set up. And the height, the height doesn't really matter right now for this, but the thickness, I'm going to say okay. I didn't set up the thickness. See, there you go. Now when I change this, the table changes. Now I'm going to set up a thickness, call it new THK, and the thickness we set up in the project, I'm going to move it down. Well, first I need to give it a non-zero value or else it will break. Make it 50. And then we select that one, edit type, come to thickness, and we get the thickness. Tabletop fillet. That was another parameter we need to think about, the tabletop fillet. So I'm going to set a new one up again, call it fillet, give it a non-zero, well, I'm going to move it down. I like to keep them in order of importance. I don't know, 150 millimeters, and then we select that one and we say fillet, and you can see it slightly changed. Okay, so now what we need to do next is we need to set up reference planes for these supports. Oh, actually, before we do that, let's set the height of the table leg. Edit type, length will be the height. Apply. And I also want the widths to be editable, so the width of this top square and the width of that bottom square. You could even make these other things editable, but I'm not going to do that. I don't see the need right now. You can even make the height of the top piece editable by doing these exact techniques. Set something up in there and then make this equal that. If you don't know what I just said, just do what I'm about to say for the square. So I'm going to say leg W1. That's what I'm going to name the top width. I'm going to make a new. Sorry, I thought I edited one. Leg W1. And then, it's least important, because you don't want to play around with those too much. Well, you wouldn't be likely to play around with them too much in the project. Things you're more likely to change go at the top. That's my methodology. It doesn't really matter what methodology you use, but try and keep it clean and tidy. Anyway, so I'm going to say 75 millimeters and then 50 millimeters. Give it a non-zero number before you start applying it. Edit type, leg W1, that one, leg W2, boom, brilliant. Now, support. Yeah, I'll make a support height. Again, that will go down there. And I will give this, oh, remember we need to give it a non-zero value, make it 50 millimeters. Remember that this one's, we don't want to edit that. Oh, the thickness as well. That's an interesting one. Yeah, we'll give it that one. I didn't give it that one in the previous one. So, well, the introduction one. Support thick. Again, non-zero value, 25. Apply. And edit type. Oh no, wrong one. Support thickness. You could even put an equation in there to make it a coefficient or a division of the thickness. There's so much you can do with this. That's it, really. That's all the parameters done. The parameters for the things we've made before are all done. Now we need to worry about the new parameters we want to put in, which will be things like, ooh, sorry about that, how far from the edge we want to place these, and where these will go, and where these will end. So I'm going to pause this real quick and think about how I'm going to do that. Right, so before we continue, well actually no, I'm going to do this bit first. I'm going to just move that leg out there. I'm going to select this one, type CS for create similar. I'm just going to offset 100 millimeters. That one, that one, that one, that one. We'll call this one, I'm going to type DI for dimension. I like to keep my dimensions on one side, nice and tidy. Ooh. I'm going to call these, hold on, we're using control button, support offset. That is going to be from the edge of the table to the edge of the support. Oh, and another thing I did is I went into the support model, I went into the parameter and I changed this length. Just so you know, length is from that to that. Don't worry, all you have to do is do exactly this. Go into it, click this, hit length, edit, and change it to an instance parameter. For that, the reason for that is because I want different lengths within the same project. I could create, I could have created some, could have created a subtype, but nah, I'd just like to create this one. Oh, that is a shout, actually. Anyway, it doesn't matter. Either way, they both work. And there's not a right or wrong way. There's multiple ways of doing the same thing. So, type AL for align that reference plane to that, lock, and I can just drag it back. No, yes, please do the instance way, because I remember what I was having some serious problems with the legs of this. I'm gonna select that one and hit DM and AL for align. Always remember to align. Select this one and this one. Type RO for rotate. Check copy. AL for align, that to that, that to that. I forgot to lock that one, so that one to that one, lock. Oh, by the way, I'm going to double click this one, go into floor plans, select all of these. I know some of you lot are probably, shift, only the reference planes here. you need to make these things tidy like this, or else it becomes very annoying. And I'll load into project and close. Yes, I will save changes. Yes. I don't want those reference planes snappable over our existing version. It's all good. So now when I click this one, I don't see that reference plane anymore. Right, so that's all aligned. I can drag these in now. Boom. Right, now we're going to move this here. RO for rotate. Copy is not checked, so that's good. Rotate it 45 degrees. So now we need to edit this table leg. I did this one earlier. The only thing we're going to edit is we're going to add these 4 reference planes, yeah? I'm going to show you how to do that now. I'm going to delete them. So select this, 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 that, that. Those are the outs. Oh no, sorry. Go to 3D mode first. Select this. Now, without clicking anything else, hold Control. Select this, this, and this. This, this, and this. Type HI for hide isolate, and we only have that piece that we highlighted in 3D mode. Yep, see. And the reference planes. What we need to do now. Oh, HR. These reference planes as well, I put them in earlier. I'm going to unpin them and delete them. Select previous. HI. Oh dear. HR, right click, select previous. That. I mean, at least you get to see my shortcuts. HI to hide isolate. Well, to isolate. That's the shortcut for isolate. So what I need to do is I need to create reference planes that go across. So I'm going to type RP for reference plane, there to there, and there to there. I'm going to pin these now, because as these center ones are pinned, they can't move, and I want these to be the same, immovable. So anything I align to these, those will move and these will stay. Now I'm going to select this and say CO for copy, there to there, press enter. To do that again, I'm going to select multiple this time, then escape, and then same here, enter, there, oh sorry, select that one and press enter, there to there, and there. Now this is where it gets interesting. Pythagoras Theorem, you need to know that. Oh, here it is. So I'm going to make a new one of these. As you can see here, we have a triangle there, there, and there in each location. It's in a square, so that means that of this square we know distance x, which means that this is x divided by 2, and that's x divided by 2, and so is this, because it's a square. I mean, it doesn't look like a square, but yeah, imagine. So if we isolate this particular triangle here, we get, let's call this A, where A is half x, and that's A. We have a right angle here, and we have 2 equal angles here, and we want to know B. So the equation for that is A squared plus A squared square root B equals that. So B equals 2, the square root of 2 times A. You don't need to worry about these calculations, by the way. I'm trying to think. So I'm re-recording this a bit. I'm going to explain to you. You don't really need to understand the maths of it if you're a bit lost. You just need to follow my equation at the end. But I'm going to explain the mathematical side right now for those that are interested. This is basically basic Pythagoras theorem. So this length and that length are equal because this is a square. We need to find out this length, and we need to tell Revit that that length, the length from this point to the center, yeah, we need to use a calculation to find this length from that point to there using only the data that we have, which is the length of each side. Yeah, and so Revit will tell this reference plane to stay at that point at all times, and we need to do that mathematically. So Pythagoras theorem, if I take just that triangle there it is, that little triangle, and we know that whole distance x, we can calculate what that distance should be, and we can tell Revit to keep it at that distance at all times, no matter what distance this changes to. Yeah, so if we take that triangle out, we get this triangle, and let's say this is A and this is A, so those two are both equal. We know these angles are equal also because it's an isosceles triangle. We want to find B, so B equals A squared plus A squared, which makes it 2A squared, and the square root of those is the square root of 2 times the square root of A squared, which is A times root 2. Now we know A is half of the entire length, so to apply it here, we'll say half of A. So from this point to that point equals, because we only have this distance here, nothing else, half of A times the square root of 2 will give you the distance from here to there. I'm sorry about the messiness of this, but if you are confused, don't worry, just copy my equation. So I type di for dimension, and I give this a parameter. That way you just name it. I made one earlier, obviously, so I'm going to give this one that parameter. I named it corner. So all you need to type is this, and if you've named, so I named the top square parameter, I named it width main. Whatever you named that's what you'll type in here. The rest of it will be exactly the same. Yeah, bracket 0.5 times the name of your top width, times 2 to the power of 0.5. The square root of anything is 2 to the power of a half, or 0.5, as you can see here. And so what I'll do is I'll type di again, and I'll do it from there to there also, and there to there. Or I mean, what you could also do is put a dimension here, make it equal. I mean, if you get any problems, oh sorry, undo, that one's already done. Oop. Make that equal, and move that one and call it corner. And yeah, that's it. And then close everything down, HR, and test it out. I think this is the width. Yeah, the corner moves with it in that exact spot. I'm going to load that into the project now. overwrite existing version. And I just realized something. When you select these, you need to make sure they are a reference. I'm actually going to hold control and select them all and change it to a strong reference. The reason for that is I want that to be snapped first before other references around the place. You could actually make everything not a reference, except I would recommend making these three a reference, those three, these X's, and these. Everything else, I'm going to actually hide those. How do you do that? Hide element, select everything here, filter, reference planes. Yep. Oh no, they're all different, so that's why there's nothing there. I'm going to say not a reference, type HR to reset, and now the only things I want to be references are references. Load into project, overwrite existing version, yes. Now, I had some real problems with these. The only way to make this work is by arraying it. You can't copy and align them to each corner, to each side. It just doesn't work. So either array it this way or array it that way. I'm gonna select it, type AR for array, just array it like that. Oh, sorry, undo. Click it, type AR for array. Make sure you've checked last, yeah? Keep it grouped and associated in a straight line. Don't worry about constrain. Don't worry about the number either, we only want 2. So I'm going to select this, and the array, say CO for copy, and there you go. Now, those reference planes, I'm going to align them AL, that reference plane, to the new reference plane I just put in, which is there. You'll only see the part of the reference plane that is in the model, within the constraints of the model. And lock it. Always remember to lock it. And then from there to there and lock. So now there to there and lock. There to there and lock. Same on this side. Should really have checked multiple align, but whatever. Cool. Now, when we edit the width, sorry, I want to move that up. Remember to keep everything in a nice order. Length, width, height, thickness, then support offset, then fill it, and then support height and thing. Cool. 2,500 millimeters and 1,200. There you go. Brilliant. Brilliant. Now, next thing we need to do. We need let me think for a sec. Right. So this line, although it doesn't look like it, as I mentioned before, these are the curves below, but that goes right to the corner. This point here is the corner of the top square. So now we need a reference plane from there to this corner, and same on that side, and that will tell us where to end this line. Now remember, it's from this end point, yeah, not that point there. The way I've set it up is from this one. You can set it up differently if you like, but you've probably already done it my way, so you'll do it my way. Either way is fine though. Don't worry about it. I'm not taking a piss or anything. Sorry, I'm not. Mind my language, please. Okay, so what we're gonna do is we're gonna type RP for reference plane. We're gonna offset 150 this way, that way, that way, that way. Now we need that Pythagoras calculation. Hold on a minute. Yeah, so remember the parameter we put in, leg W1, that is the width of the top square. See, in this other one, in the leg itself, it had a different name. The name I gave it at the time until I realized. So I gave it width main. But generally, we're going to do the exact same thing here. We're going to give the distance between this and that the same Pythagoras Theorem equation. So I'm going to come here and I'm going to copy that. Control C, doesn't let you right click. DI for dimension, there to there. Select it. As I said, I like to keep things tidy. I'll just name it C. Do not touch, just to make sure no one messes with it. No one's going to mess with this one, but it's for you to know. Please don't touch it. Right, so C, I'll paste that in here, Control V, and remember I've got to change width main to leg W1. Sorry, it's case sensitive. Leg W1. Apply. Now it's perfectly in line. So I need to do that again. Type DI for dimension. And there. Select that, and select that one. That one's already done. Give them the letter C. Oh, and just make sure it's all the way at the bottom. Yeah, good. Now, simple. AL, align that to that and lock. That one to that one and lock. That one to that one and lock. That one to that. Oh. Lock it. Oh no, this one. And as I said, it doesn't look like it's correct, but it actually is. If you look at it in 3D mode, it stops perfectly at that point. Yeah, cool. And remember the curves in here. We can actually give those parameters as well. I'm not going to, but you can do that if you like. Yeah, that's it. That's our project done. Let me again show you. And it takes supreme confidence to change them all at once, because something usually breaks. However, I am very confident that this works. Support offset, I don't know, 150. Fillet 200. Support height 60. Support thickness 50. Leg width 1, 60, leg width 2, and 45. Don't touch C. There you go. Genius. 500 to 500. Ooh. There you go. Done, done, and done. So obviously, as I showed you in part 0, you can now load into project. Oh, I haven't got a project open. Open a project. Any project. Crane, yeah. We'll go with that one, that one, that one. Yeah. I can load this in now, and yeah, that's it. Load into project and close. Sorry, not close. Load into project, crane grid. And here you go. Can place it nicely there on that thing. Yeah, and then you can play around with it here like this. I'm going to change W1 to 75 because it looks a bit skinny. Need to give it some meat. Boom. Done, done, and done.